All right, so this problem is from our problem set. It is the box on the conveyor belt, and the conveyor belt is moving the box at a constant velocity up. And in the problem, they give us the mass of the box, the angle that the conveyor belt is tilted at, and the total displacement of the box. I'm going to do this problem with all the variables, so I'm not going to substitute any numbers in. That's because it can be confusing if you substitute numbers in. You start to forget what things actually stand for. It also causes rounding errors, so it's a good practice just to leave those variables in till the very end. The next thing I did or thought about was that displacement. I knew that the displacement could be broken down into components in the same way that forces can be broken down into components. So I wrote that out, and the displacement that is going to become important in a minute or so is the vertical displacement. The next thing I did was I drew my diagram again. I love drawing this diagram over and over again. And this time I just show the force due to gravity, mg. Sometimes when I'm drawing free body diagrams, if I have a total force and then break it into components, I start to get confused. I'm easily confused. So I did this separately from my final free body diagram, and I figured out the force of gravity along the plane of motion and the force of gravity perpendicular to the plane. And so now here I am drawing this free body diagram again, and I'm only going to write in my components. So I've got my two force of gravity components. I have my normal force that is equal and opposite to that force of gravity perpendicular to the plane of motion. And then I also have the frictional force that is equal and opposite to the force of gravity along the plane of motion. I'm not going to talk about positive and negatives in this video, and I do neglect to add them. That's really something I would think about at the end when I realize that they're asking me for positive and negatives in my answer. Okay, the first value of work I'm going to consider is the work that gravity does. So I know gravity is pointing straight downward. Instead of trying to worry about my components of gravity, it was easier for me to think about gravity as just mg straight downward. So that's what I did. It's not the only way you could figure this out. You could use the components. I just found that I was confusing myself by doing so. So the work that gravity does is going to be the total force of gravity, but only in the acting on the vertical displacement. So my force of gravity is mg, and my vertical displacement is the d times sine theta. And so the work that gravity does is going to be mg d sine theta. Okay, I tend to use a lot of paper when I'm solving problems. It just helps me think and helps keep me organized. So I still have my force diagrams, but I'm starting a new page. And what I'm going to consider now is the normal force and the net force. So if forces are perpendicular to the plane of motion, they're not going to accomplish any work. The work is only done along the plane of motion. Remember, work is force times displacement. So if the normal force is perpendicular to the plane of motion, it does no work. So that force, or that work done by the normal force, is 0. Now, I want to talk about the net force. Because the box is moving at a constant velocity, there's no net acceleration, and so there's no net force. Well, since work is force times displacement, if there's no net force, the work done by that net force is 0. I found this kind of an odd question to ask because the net force is really just adding up everything else in the free body diagram. And so the idea of a net force accomplishing work seemed just strange to me conceptually. But you could say it. It's just another way of thinking about the problem. Okay, a new page, and we have 2 more quantities to consider. The work done by friction and the work done by the conveyor belt. So let's start with the work done by friction. I know that I already wrote the force of friction in my free body diagram. I said it was mu, the coefficient of friction, times mass times gravity times cosine theta. Now, when I wrote this out, I forgot, because I wasn't substituting in numbers, that the problem didn't give us a value for mu. So I had to pause and consider for a moment, well, if it didn't give me mu, I must not need it. Now, you can't do that for all physics problems because, well, sometimes they make mistakes. But in this case, the frictional force is equal and opposite to the gravitational force parallel to the plane of motion. So while I wrote that the frictional force here is mu times mass times gravity times cosine theta times displacement, I should have used the mass times gravity times sine of theta times displacement. So just note that. The last thing is the force of the conveyor belt. Now, this really kind of threw me for a loop because the conveyor belt is responsible for the normal force and the frictional force. But we already said that the normal force isn't contributing to any work that's being done. And that's okay. So we would say that the force that the conveyor belt is applying is the normal force plus the frictional force. Because remember, friction is essentially the conveyor belt, right? The conveyor belt has friction. Because the normal force doesn't count in terms of the work that's being done, we only need to think about the frictional force. Well, that means that the force from the conveyor belt will be equal to the frictional force. I didn't particularly like asking the question that way, and I found it somewhat confusing, but once I thought about where they were coming from and what they were getting at, it does make sense. I'm hoping that cleared up some of the questions people had about this problem. If not, of course, you can always send me an email, and I'd be happy to field any questions via email.